Hi, in this lesson we're going to talk about how to solve absolute value equations. These are the ones that I'm going to talk about here are going to contain only one absolute value symbol. So when we do it, we're always going to isolate the absolute value first, but let's quickly use this first example to understand what we're dealing with. So we're trying to solve absolute value of x equals 4. Absolute value represents the distance between a number on the number line and the 0. So where are the numbers whose distance is 4 units away from 0? It's going to be positive 4 and negative 4, right? This is negative 4 and positive 4. They're both 4 units away from 0. Those are going to be your solutions. But how do you do it algebraically? This is what we always do. We're going to write x equals positive 4 and we're going to write x equals negative 4. So basically remove the absolute value and set it equal to a positive value on one side and then negative value on one side, and this is actually going to be everything. We do need to check our solutions. It does not apply to this problem, but in other problems we do. Let's go ahead and take a look. So here's our example 2. So what are we going to do here? We're going to, since the absolute value is alone, we're going to say x plus 1 equals 6 or x plus 1 equals negative 6. We solve each equation, which this one gives us x equals 5. This one gives us x equals negative 7. We can check. Absolute value of 5 plus 1 is 6. Absolute value of negative 7 plus 1 is going to be the absolute value of negative 6. It is 6. So these are, well, let's check. I just want to show you this. 5 plus 1, absolute value is 6, true. And here it's going to be negative 7 plus 1, its absolute value of 6 is also true. 5, negative 7. Okay, in this next problem, the absolute value is not alone. So what we need to do is we need to get rid of this 4 first. And then we're going to have absolute value of 2x minus 1 equals 5. Then we'll follow the same procedure. So 2x minus 1 equals 5, which gives you 2x equals 6, x equals 3. Or we're going to have 2x, I shouldn't put or here, should be here. 2x minus 1 equals negative 5, which is 2x equals negative 4, and x equals negative 2. Okay. We check them, we substitute them into our equation, they both work. So our solutions here are 3 and negative 2. Alright. Next problem, we have to lose the 2 on the left hand side. So the absolute value of 4 minus x is going to equal 5. So now we can write two equations. 4 minus x equals 5 or 4 minus x equals negative 5. So this one here is going to give you x equals 9. And this one is going to give you x equals negative 1. If you plug them back into the equation, they will work. I will show you problems where it does not. So we have 9 and negative 1. And you know what, I'm going to write here to remember to check them. Okay, next problem. Minus 6 minus 6. Absolute value of 2x minus 1 equals negative 5. Okay, this is where you should stop. Here's why. Absolute value is something that's always going to be positive or 0. Absolute value cannot equal negative number. That is not possible because it's defined as distance. So when you see an expression that says that an absolute value equals a negative number, it should tell you right away that it's not possible, and the answer here is going to be no solution. Okay. You can continue solving that, but the problem is you will waste time And if you don't check your solutions that you're going to get, because you will get a couple of numbers, you will write them down and they will be incorrect. What do we do when we have a variable on the other side? Nothing's going to change. Nothing. So we're going to have 2x, well, first of all, the absolute value is alone. So 2x plus 1 equals x plus 2. Or we're going to write 2x plus 1 equals negative x plus 2. So this here is going to give us x, if you solve this equation, is going to give us x equals 1. Here we need to make sure we distribute correctly. It's going to equal negative x minus 2. And when you solve this equation, x is going to be negative 1. Do they both work? Let's see. I'm going to start checking these. So it's 2 times 1 plus 1 equals 1 plus 2. That's 3 here, 3 on the other side. Good. Here, negative 1. So we got 2 times negative 1 plus 1 equals negative 1 plus 2. This is going to give you negative 2, so it's 1. 1 works. Both good. This next problem, we need to move the 3. It's going to give us the absolute value of x plus 1 equals 2x minus 3. And we're going to write two equations. So x plus 1 equals 2x minus 3, or x plus 1 equals negative quantity 2x minus 3. So this equation, you solve it, you're going to get x equals 4. When you solve this equation, well, first of all, x plus 1 equals negative 2x plus 3, and that's going to give you, when you solve it, x equals 2/3. Okay, when you check, this one's going to give you 4 plus 1, absolute value equals 2 times 4 minus 3, which is 5, and 5, this is true. We're going to have a problem here. I'm going to do it on the side here. When you check, so it's 2/3 plus 1 equals negative 2 times 2/3 plus 3. So 2/3 plus 1 is going to give you 5/3. On this side we're going to get negative 4/3 plus let me see, negative 4/3 plus 3. No, actually I think it's going to be fine. Yeah, it's fine. I'm sorry, I looked at the wrong problem. So 5/3 equals 5/3. It's good also. So we have 4 and we have 2/3. Okay. Moving on. Example 8. So we're going to have x minus 1 equals x, or x minus 1 equals negative x. So this equation here, when you try to solve it, is going to give you negative 1 equals 0, which has no solution. This equation here, you're going to get 2x equals 1, x equals 1/2. So nothing to check here. To check 1/2, we're going to have 1/2 minus 1 equals 1/2. So it's negative 1/2, absolute value equals 1/2, which is actually true. And the answer here is going to be 1/2. Alright. This problem, example 9. So we have this, so we're going to do x plus 3 equals x plus 1, or we're going to do x plus 3 equals the opposite of that, so it's negative x minus 1. Here we're going to get 3 equals 1, which gives you no solution. That's a false statement. Here we're going to have 2x equals negative 4. which gives you x equals -2. So everything seems okay so far. Let's check this number. So we're going back into the original equation. -2 plus 1, I'm sorry, plus 3, absolute value, equals -2 plus 1. This gives you 1, this gives you -1, this is false. So this does not work. This is what we call an extraneous solution. And our answer here is going to be no solution. Okay, I have one last example. I've seen, you might have seen this problem before. They sometimes come up in different math groups. So x minus 5 equals 5 minus x, or x minus 5 equals -5 plus x. So what happens here? This one's going to give you 2x equals 10, gives you x equals 5. On this side, we're going to get -5 equals -5. So it seems like it's all real numbers. But I want to remind you, when we wrote that, we want to make sure that 5 minus x, because we want this to equal that. If it's absolute value here, this quantity here must be positive. So we want for 5 minus x to be greater than or equal to 0, which means x is going to be less than or equal to 5. So what does that mean? That means the solution here is going to be when x is less than or equal to 5, we're actually getting an inequality. Yeah, so it's going to be from -infinity to 5. And we already got 5 here and 5 here, so we only need it once. Alright, and that's it.